The whale is one of the most unique mammals on Earth. Much like bats are to air, the whale spends most of its time underwater, catching food, mating, and giving birth.
Belonging to the cetacean mammalian branch, the whale possesses an anatomy vastly different than most mammals, with a large tail occupying most of its body, small flippers on both sides, and a large head. This unique physiology is the result of natural selection, the process in which animals with favorable variations survive, while animals with unfavorable variations die out. In the case of the whale, this process involved a radical change over time of the skeletal structure, including the shrinking of the pelvis, hind and front legs, and the growth of the head and vertebrae.
To find the origin of the whale's evolution, one must look at its ancestors, the first of which is believed to be some kind of artiodactyl, the family from which cows, hippos, and camels originated. Though this early ancestor lived on land, it fed on both land animals and fish. This need for fish must have increased over time, and over thousands of years, this early artiodactyl had evolved into the Pakicetus, which thrived on land and in the sea. Possessing large hind legs, webbed feet, and a stronger tail, the Pakicetus was well suited for the ocean. Over millions of years, perhaps overpopulation or the need for more food caused the evolution to the completely aquatic Dorodon. The Dorodon's skeletal structure underwent major changes over the eons. The large pelvis required to support Pakicetus' weight on land had shrunk drastically. The elbows and wrists of both pair of legs were no longer needed for walking and fused, creating flippers, and a large fluke formed at the tip of the tail. All of these were evidence of natural selection. Furthermore, the two families of cetaceans formed from the Dorodon. Through the process of speciation, the Odontocetes, ancestor of the dolphin, and the Mysticetus, ancestor of the whale, formed. These two families became separate through reproductive isolation, as they cannot interbreed.
Give up.
A University of Michigan team of researchers in 1977 discovered that in the fossils of ancient fish, their pelvis fragments indicated that the fish were large, walking beasts. This probably connects to the whale. Whales are the predominant group of massive mammal-based creatures. A few years later, in a relatively close region, they found a wolf-like creature that had cetacean whale characteristics. The early whale could have been a large, meat-eating predator with hoofed-like feet that had interesting jaw structure. Additionally, another fossil, dated 100,000 plus years ago, suggested that the whale had tiny hind limbs. The hind limbs were so small that they couldn't be used for walking or swimming. They were likely used to aid in sexual reproduction.
Another method used to determine the origin of whales was homology, the process in which scientists determine the relationships between animals by analyzing bone structure. In the case of the whale, two connections were made between the cetacean physiology and the physiology of artiodactyls, such as hippos, the mammalian structure of the forearms, and the similarities of the knuckle bones. Scientists use these similarities to confirm that whales are in fact artiodactyls.